Enterprises built highly structured digital pathways to handle repetitive work. But when an unexpected variable drops onto a rigid system, those pathways shatter. Organizations have automated more in the last 5 years than in the previous 2 decades. Dashboards replaced spreadsheets, bots took over repetitive clicks, forms went entirely paperless. But the real operational friction rarely lives in a single predictable task. It lives in the handoffs between departments, the unmapped exceptions, and the highly specific, variable decisions. Traditional automation makes work faster in stable conditions, but it cannot adapt when real-time, mid-flight events force the process model to bend. This friction is forcing an architectural shift. The focus is moving away from isolated task execution and toward intelligent business orchestration. The objective is to automate complex, dynamic decisions while maintaining strict structural governance over the entire workflow. Surviving modern operational volatility requires systems that synthesize context and adapt as events happen, rather than simply executing static instructions at a higher speed. This flowchart maps the architectural shift through 4 distinct stages. Stage 1 is standard workflow automation. This represents the baseline, standardizing how a request moves. But when this flat process hits an unmapped exception, it stalls completely. Stage 2 patches this. AI tools are bolted onto the exterior of these workflows to push stalled processes forward. But the AI in this stage operates in a silo. The tools are advanced, but the system visibility, control, and governance lag far behind the new cognitive capabilities. Stage 3 resolves this silo. In AI-powered orchestration, the architecture expands. Central nodes now coordinate people, systems, data, and intelligent decisions comprehensively across the entire enterprise network. Because the system handles the complexity of executing the tasks, the operational burden shifts entirely to integration and maintaining accountability across those connected platforms. That deep integration sets up Stage 4, agentic processes. Here, AI agents actively monitor the mesh, manage exceptions, and propose real-time adaptations to the data pathways as soon as new event triggers appear. Achieving true enterprise autonomy requires an under-the-under architecture that coordinates decisions across the entire system. Adding more AI tools to a fractured foundation will not achieve this level of operational control. There is a persistent assumption that deploying an advanced language model instantly equates to enterprise-grade autonomy. The reality is that isolated models lack operational context. To function accurately, AI requires deep, real-time access across a web of specific applications and data sources. This matrix shows what happens when organizations skip orchestration. They fall into one of 2 integration traps. The first is fast but ungoverned. The AI makes rapid decisions, but because it is disconnected from the core compliance system, there is zero auditability. The second trap is governed but slow. The core system is heavily locked down, so every exception flagged by the AI triggers a manual escalation alert, creating a severe operational bottleneck. Both failures stem from the exact same architectural flaw, separating the system's cognitive capabilities from its structural control. Deploying AI without a central orchestration framework creates immense organizational risk. You either lose necessary oversight, or you paralyze your operations with manual reviews. The solution to the orchestration paradox is to build a bounded agent architecture. This diagram illustrates the 3 foundational layers of that architecture. The first is Business Process Management, or BPM, which acts as the rigid central spine of the workflow. BPM defines the exact guardrails. It serves as the deterministic, auditable source of truth that ensures strict enterprise compliance at every step. The second layer is the event-driven architecture. This functions as the system's nervous system, feeding real-time state changes directly into the process model. Instead of waiting hours for a scheduled batch update or a manual human prompt, the system reacts immediately to specific real-world event triggers. The third layer is agentic AI. This operates exclusively as the cognition engine, positioned strictly inside the established BPM guardrails. The AI agent analyzes incoming events, synthesizes the critical context, and proposes actionable decisions, handling highly complex, ambiguous variables. The strict architectural rule here is that the AI accelerates the thinking, but the BPM process retains total control over the execution. The process dictates who approves and what gets logged. This securely bounds probabilistic AI models within deterministic, auditable process rules, giving you intelligence without chaos. This swim lane diagram illustrates how the architecture scales in a high-stakes banking fraud dispute. We have dedicated lanes for telemetry, the AI agent, the BPM core, and the human approver. A suspicious merchant pattern instantly fires an alert from the telemetry layer. The data packet travels into the BPM core and activates the AI agent. The AI agent immediately synthesizes the customer's travel history, reviews recent account changes, and factors in regulatory constraints to propose a compliant next step. The BPM core then takes that proposal, automatically enforces the required human approval routing, and permanently logs the rationale to guarantee compliance. We see the same architecture applied to physical infrastructure. A sensor detects a massive industrial machine component vibrating dangerously, trending toward imminent physical failure. This severe telemetry event automatically bypasses standard reporting protocols to instantly open an active maintenance case. The AI agent analyzes historical maintenance logs alongside current production schedules, then proposes a controlled line stoppage directly to the floor manager for final sign-off. In both scenarios, the orchestrated architecture successfully scales complex decision-making based on real-time data without bypassing mandated human oversight. Transitioning to autonomous processes involves a fundamental shift in the operating model. Success requires structural changes that extend far beyond a standard software deployment. Success requires strict prerequisites, establishing clear AI governance, ensuring upstream data hygiene, tightly securing the central orchestration layer. This brings us to the ultimate benchmark for evaluating any enterprise AI deployment. If your system cannot explicitly explain how an AI decision was made or prove that it adhered to corporate policy, you do not have intelligent orchestration. You simply have risk wrapped in speed. Building rigid BPM guardrails is an urgent necessity today, long before fully autonomous agents become standard market practice. Establishing this foundational orchestration mesh right now ensures that as your AI capabilities scale, your operations remain structurally sound and entirely auditable. Future enterprise technology depends on orchestrating governed decisions across the business, replacing the reliance on isolated task automation.